Okay, if 2 log base 3y plus log base 3x squared is 4, let's find y. Okay, what we will try to do is to use the multiplication law because we can see that the bases are the same. So let's explore the multiplication law. But then there is 2 at the back here. Let's see how we can take this up here. You know that law of indices that says log, no matter what the base is, when you have y raised to the power 2, that's, let's just use y as a number, raised to the power 2, you can take that power to the back and it becomes 2 log x y, right? Good. So let's just use that to take this up, right? So we have log base 3 y raised to the power 2. Okay, we just did the reverse of this, went from this to this. Okay, so took it back, and then this is already positioned like this, so we are good. We'll just rewrite that log 3x squared equals 4. All right, now that the bases are the same, there's a law that when you have log, no matter what the base is, x times y, all right, you can rewrite this as log. I'm going to need to change this to a. Okay, so it doesn't look like they are the same number, because whether they are the same or not, the law stands. So a now plus log base x y. Okay, so multiplication can be made into addition like this, and addition can be made into multiplication like this. So I'll apply that here. So we'll have an addition. I want to put it in this form. Okay, the reason is we have common base. I want to see how we can make it just one logarithm presentation there. So log base 3. So we'll multiply this to this, preferentially in a bracket. So y squared x squared equals 4. All right, we've applied 2 laws of logarithm there. There's a way we can simplify this. Y squared x squared can be y x all squared, right? Let's do that here. So log base 3 y x all squared equals 4. Okay, now there's a law of, let's look at this. We all know that log, you can get this from a calculator, log in base 10, so I'm not going to put a base, when there is no base, it's base 10. Log 100, of course, in base 10 is 2. This means 10 being the base. Okay, let me put the base there. Okay, 10 raised to this power 2. That this 10 now, that's this. I rewrote this 10 here. Then this result here, I wrote it as a power of 2. I'm writing it as a power of 2 is equal to 100. So we can always rewrite that log x y equals z. This raised to this power, that is x raised to power z, all right, will always be equal to y. This is the third law we're applying today. Okay, so 3 raised to power 4, 3 raised to power 4 will always be equal to y x all squared. Let's make this power 2 so we can, compare the bases properly. We've moved from logarithm to indices now. So this is 3 raised to power 2 raised to power 2 again, because 2 times 2 will give us 4. The plan is just to make it look like the right hand side. So y x all raised to power 2. So if we take out these and these, it means these two are equal. That's 9 is equal to yx. Well, we're supposed to find y. So y is equal to 9 over x. Super easy.